Alrighty, so now we're going to talk about how to migrate your Windows workloads into AWS. Okay, so we're going to cover the migration process itself, how you'll migrate data, migrating your databases, and lastly, migrating your servers. And then we'll also talk about how to handle legacy workloads, such as those that are running on Windows 2003. So the migration process itself is 5 steps, and this is following best practice designed out by AWS and AWS partners. And what we found is, although some people may have a desire or a concern to migrate legacy applications in isolation, chances are you're probably doing the migration as part of a larger enterprise transformation effort. So this is essentially the 5 patterns that we see, or the 5-phase approach that we see. And we have access to partners such as Cloudimize, CloudChomp, or even AWS tools such as TSO Logic, now called Migration Evaluator, to help you look at the migration process as a whole and help plan out how the migration should occur and any dependencies that may come up along the way, and then how to best remediate those items. Okay, so it all begins with a migration readiness assessment. We use that to evaluate customers' current states for the cloud journey, and it helps them prepare for a larger migration to AWS. The readiness assessment is a process that evaluates your status against the cloud adoption framework and puts a lens or exposes where your organizational, technical, and capability gaps are, what you need to address prior to the migration, and then also makes recommendations for items that you should do in order to mitigate those gaps. We believe that this early evaluation for your readiness, along with the migration readiness and planning engagement, which is a engagement that we recommend you do at the start of any migration initiative, will reduce your risks, any delays, and potential costly overruns as part of your migration process. Okay, so now let's talk migration strategies. What are your options and how you should consider your migration? So as you see here, there's several different types of methods that you can choose from. Rehost, replatform, repurchase, refactor, retain, or retire. The 6 R's of migration. Beginning with the top one and going down will usually be other than retain and retire, they increase in level of effort. Rehost is essentially moving from your current data center and plopping it onto AWS. We have access to tools that make the migration rather easy. For example, AWS Server Migration Service or Cloud Endure helps automate that migration process in a pretty rapid fashion. You can choose, if you don't want to use the automated tools, to do a OS install or launch from an EC2 instance, then install your applications, configure, and deploy. Typically, we will see that occur when a customer wants to, say, jump into a new version of an OS or jump into a new version of their application without going through any sort of upgrade path, basically clean out any technical debt that may be in existence with their old system. Replatform is another method. Basically, this takes what you have and decides whether to take it from an EC2 instance, move some of the services over into either a container or RDS, and then modify your infrastructure as such using any sort of migration tools that you need. Repurchase would be moving in your applications into some sort of SaaS product, either that's already available within AWS or something else, and then running it within EC2. And then lastly is refactor, which is the most involved. However, you'll probably see the best bang for your buck because you're basically redesigning your application, recoding it to take advantage of all AWS services. So you're not having to run, all your applications. You can choose to move some of your functions into Lambda, move your RDS, or move your SQL Server into Lambda, or RDS, and so forth. All right, and then lastly, retain and retire. All right, so now let's talk about migrating your data. What's the quickest way to do it, to copy your data over, and what are your options for doing such? Okay. As far as connectivity and getting your data in, AWS provides a number of services. Direct Connect, which is an ISP or your ISP line, providing essentially a direct connection into an AWS region. Snowball, where a large storage device is sent to your on-prem location. You copy your data over, shift it up, and ship it off into the cloud. Very useful for when you have terabytes or petabytes of data. There's multiple different sizes of within the Snowball family now that you can choose from. Storage Gateway is an option where you will launch a virtual machine on your on-premise network and start backing your data into mounted volumes offered by the Storage Gateway, which is then replicated up to S3 AWS. You can utilize technology partners that AWS has to move the data over. Kinesis Firehouse is an option for you if you want to move large volumes of data that is occurring at high volume from different sources on up. And then lastly, transfer acceleration. This one is used probably for more smaller data sets where you are uploading to S3, you can choose local regions, and the transfer, once you transfer up to the nearest region to you, the rest of the data travels over AWS's private network and gets to the final region of choice more quickly. All right, so now we'll dig in a little bit deeper into each of the items, and basically you're looking at your time that you have versus the volume of data that you need. And we'll look at the various different options. As you can see here, it's all really based on how fast you want to move your data and how much data that you need. So first, looking at Snowball Edge, this is an extremely scalable. As I mentioned, there's multiple options. There's the new Snow Cone, which does, I believe, 4 terabytes of data. The Snowball itself, which does approximately 80 some terabytes, and then Snowmobile, which is the big semi-truck, and lets you move petabytes of data. The Snowball Edge has the features such as their high network interfaces. It comes with Ethernet, fiber, etc., to allow you to plug in, depending on what you are currently running in your data center. plug it into the Snowball, and then copy your data over. Your data is encrypted as soon as it enters and gets stored onto the Snowball. So even if the device was intercepted during transport, nobody would be able to retrieve that data. And you manage your jobs via the console or API. Real quickly, the path on, or the process for how Snowball Edge works is you create a job within the management console. You connect the Snowball device into your local network, copy all your data to the Snowball, and then ship it off. And then AWS will take care of extracting the data from the Snowball and then putting it into the S3 bucket that you have requested. All through this process, you do get notification via SMS. If you set it up, it can either be a text message, email, or some other mechanism that you choose for notification. Okay, let's talk storage gateway. So storage gateway allows you to move big data, cloud bursting data, or cloud data migration workloads that require essentially a local view and a connection to a centralized cloud storage repo. Storage gateway helps you move this data between your organization and AWS in a managed fashion, so that you don't have to worry about, did I copy this up? You just mount a volume from the storage gateway, and it is uploaded to AWS. It's a drop-in replacement for tape and tape automation if you're currently using that method, and you can use leading industry backup software packages. You get the performance of a local disk because the gateway is running locally to you, but it backs up into the cloud and it scales on the back end without interruption to your current systems. It also allows you to expand your on-premise NAS and SAN storage arrays and without having to make additional hardware acquisition purchases, and extends the life of your investment, of your software investment, and helps your organization gracefully manage capacity and eventual move into the cloud. So some of the options are volume gateway, which is what I had mentioned earlier. It presents your applications with a storage volume using an iSCSI block. The data is written to these volumes, and then it is asynchronously backed up as point-in-time snapshots, and it's stored in the cloud as AWS EBS volume snapshots. You get to set the schedule for when the snapshots can occur, and then you also can create additional snapshots through the console outside of the schedule that you want. The beauty is that the snapshots are incremental backups and capture only the changed blocks. So, and the snapshots are compressed to minimize your storage charges. In a cached mode scenario, you store your primary data on S3, but you retain the frequently accessed data in cache. So in this mode, you're essentially saving significant amount of money on your on-prem storage, because you don't actually need to have the same disk capacity that you need in real life. You just set whatever how large you want your cache to be, and the actual storage or the final storage is actually occurring in S3, which is infinitely scalable. So, and in stored mode, you store the entire data set locally, and then make asynchronous backups to S3, and then create the point-in-time snapshots or EBS snapshots. All right, let's talk about tape gateway. So tape gateway is essentially your drop-in replacement for your tape library. It's virtual tape library. Again, your data is stored in S3. You set life cycles to perform archives to Glacier. and Deep Glacier as well, and it supports most backup software. And again, it's also Hyper-V and VMware supported. Okay. Storage Gateway also offers a file gateway solution. This is based on SMB version 2 or 3 and supports NFS protocols. Your data is stored on S3, and again, it is Hyper-V and VMware support. Okay. And this here is an example of using Storage Gateway and Microsoft Distributed File System to have an HADR file system service. So you can see here where you have your on-prem, you're backing up into the West region, but then you're also using distributed file systems into your East region for your backups. Okay, now I'll hand over to Chris for migrating databases.
Great, so we're going to talk about how we can migrate databases and into AWS. I like to start this slide off with back in my day, or back in the day, we had to do things really hard. We had to take a backup of an existing database, upload it up to S3, and then import that into RDS, which for a lot of use cases is still great today. It's very simple. It uses the native backup capabilities of your on-premise services. It uses those .back files, and it's a full backup and it's a full restore into the RDS SQL database. It's pretty straightforward in terms of the process. You're going to get your schemas, you're going to get your stored procedures, your triggers, and database code all there in your RDS instance. Definitely you can think about it for your production workload, but you can also think about it if you're trying to create different environments. So if you're looking to create, a QA environment from a backup, or do testing or a proof of concept within your thing, you don't necessarily have the infrastructure. It's a great way to use AWS. More so than just for your production workloads. It gives you sophistication to try something out, a new configuration, a new database schema, etc. And so just using the flexibility, because when you're done with it, you can just spin that resource down, and you're not paying for it for the whole year, or for 3 years amortized over that time. So just new ways of thinking that AWS provides with its infrastructure. We see a lot of customers, and we do a lot of engagements with customers to utilize database migration service, which is a service that helps you reduce downtime with a migration. So it's a simple to use, minimal downtime. It supports many different flavors of databases. It's low cost and it's easy to set up. What I like about it is that it maintains synchronization of your database between, say, an on-premise system and your AWS resource, which is powerful in such that you don't have to shut down your database to take a backup, etc. And if you have a large data set that could take multiple hours, if not multiple days, to get migrated, since it's doing the synchronization, it provides you the means to get your cloud database ready by migrating that data over time, so that you're not affected by a downtime when you do finally switch over. So, it's very straightforward with like databases. So if you're trying to migrate an Oracle on-premise system to RDS, the database migration service is very straightforward. Another thing to realize is that you can use database migration service to do a database on an EC2 instance or another RDS instance, you can use this capability to do like-to-like of Oracle databases. You can also use it to use from MySQL to Amazon Aurora, which is another database option within AWS. It's a highly performant MySQL database that uses some proprietary custom configurations to give you a 10x performance improvement over just running standard MySQL. So since they're similar databases and Aurora is compliant, it's a like-to-like between the two database types. But with database migration service, you can use a schema conversion tool. And this tool is very powerful in such that it provides you a template or provides you scripting that show you how to set up your target database. So it looks at your database, it analyzes it, and gives you the means to set up the target database with the data converted for that new database type. So like if you have an Oracle database and you want to utilize Aurora, you point the schema conversion tool to it. It provides the conversion factoring, apply that to the Aurora database, and then your migration service can run and applies those conversions as part of the transition there. We see that a lot with people trying to get cost optimizations and potentially off of Oracle licensing and the like there. You can also use database migration service to consolidate multiple databases. So let's say you have multiple on-premise databases and you can take advantage of the power of Aurora. The migration service can consolidate those all into one. It also does, as I mentioned earlier, replication, so that you can migrate to different regions. You can point it to another, you can go out, you can migrate data out of AWS onto your on-premise. So if you need that replication to be occurring on a continual basis, it's very powerful for that as well, in and outgoing of AWS. Here's a chart of kind of the what works with what in terms of the source and data out. So you see a lot of your data warehouses, your Netezas, your Green Plums, your Verticas can all be targeted to Redshift. Your MySQL and Postgres can be moved into Aurora, etc. And then for SQL Server, you have the options of Aurora, Redshift, MySQL, Postgres, or MariaDB. So a lot of different options there. So talked about migrating databases. Let's talk about migrating servers. And so for that, as you might have guessed, there is server migration services. The service means to migrate on-premise systems, whether they're in VM vSphere or your Microsoft Hyper-V virtual machines. And what SMS does, kind of similar to the database migration, is that it provides increments of those VMs into Amazon machine images. As you might recall, when we launched that EC2 instance, that Windows EC2 instance, it had an AMI associated with it. So this is basically taking that concept and importing instances or your virtualized on-premise systems and building those into AMIs. Here's some supported operating systems. There's so many that I won't list them, but 2003 all the way to 2016. Windows 7, Windows 8, if you have those still running in your organization. So AWS migration server does that automation, it replicates it in, and it gets it ready to spin up on a EC2 instance. So you schedule your migration job, you take a snapshot, you provide, you can upload it into the to create, it converts it into an EBS snapshot. And then from there, you create the Omni from there. So that's kind of the workload that it takes care of for you in the process.
All right, at this point, I do just want us to break for lunch, Chris, not to cut you off. I just want to give everyone the opportunity to go get some food. You're welcome to stay and listen. We are also recording this session. Chris, please continue. If you want to ask questions as well, we'll be here.
Yeah.
But we'll resume the next session starting at 12:30.
Cool. Yeah, this is actually just the last slide here is that there's also VM Cloud on AWS. It's got a lot of news, but this is a means that you can extend your VM services into AWS regions. Basically how that works is that there's a VM environment where you can use your vCenter services, your vSphere networking, your SAN configurations, but through an elastic network adapter, you could also interact with services within your VPC. So vCenter controlling everything into your VMware cloud, but then also the ability to connect the VMware cloud into AWS resources like a RDS database or a Lambda function, etc. You know, a truly hybrid model there.